So recently I've been messing around with trying to electroplate 3D prints, specifically with copper. This could be used for either just looks or for some sort of added structural integrity. So for the first step, we want to make an aqueous solution, basically a bath of copper acetate. So that way we can dip our part in it and have the copper stick to it. So what we're going to need for that first is some pure vinegar, some hydrogen peroxide, and some copper. So this is some scrap copper wire I had. You could use anything really. But I got both of these at Home Depot. Make sure you get the pure vinegar. So what we're going to do is mix half parts vinegar and half parts hydrogen peroxide in a container that will be sized based on the part you're trying to do. So I have kind of this mini trophy here that I'm mainly going to be working with. So I'm going to measure out, I think, about 3 cups of each. So the next thing we want to do is get this solution up to about 110 degrees Fahrenheit. So I'm going to do that by popping it in the microwave. I found this takes about a minute and a half-ish. You could kind of probably get away with just estimating it, or I've got this infrared thermometer, and we'll see how this turns out. So it looks like about 2.5 minutes did the trick. Hopefully you guys can see that. So now we're going to throw in some copper in it. You'll start seeing bubbles to form quickly. So I've got some leftover little pieces. I'm going to cut some more with my wire cutters right here. But you should see immediately, you guys, my GoPro probably won't have the resolution for you to see, but there should be bubbles forming literally immediately. And basically the more copper you put in here, the quicker this reaction is going to take place. But this solution will eventually start turning blue. I would recommend at least 6 hours, but you can kind of see it should turn a dark blue. I'll try to take some pictures as it goes and throw them in the video, but I can start seeing the copper wire turn a little green and some bubbles already. And like I said, I'm just going to cut a little extra. Bend it up, put it in. It'll just speed up the process. So while this is doing this, we want to make sure our 3D print is conductive. So any sort of 3D printing plastic, whether it's PLA or ABS or whatever it may be, is not conductive. So we need to coat it in something to make it conductive. So I'm going to go over a couple variations that I tried, some with better success than others. But first we need to clean this. So what I recommend are rubber gloves, and then either some general degreaser, or I have some brake cleaner. One second. So I'm about to clean this part, so you might want to open a window, but here's some general AutoZone brake cleaner. So I'm going to spray this just a little bit, have a paper towel ready to put it on to let it dry. But this is a solvent, so it'll clean it right up pretty quickly. And then we're going to let this dry. So I'm going to talk a little bit about the different conductive materials that I tried before I go over actually measuring the resistance of them and showing you definitively which one's the best. But so I had one thing that's not pictured is I had this straight up copper paint that I thought would work, but absolutely did not work. It works as in it'll coat it and make it look like copper, but as far as making it conductive, it won't even register. My first try, what I did was I went to Home Depot and bought some powdered graphite. It's usually in the section with all the locks, so it's used to lubricate locks. And you mix that with acetone and then paint it on. So this was the result. So this is that powdered graphite and acetone. This would be the next worst of the things I tried. The other thing I found was some graphite spray, so some dry lubricant, and I would spray on multiple coats. Here's an example of something coated in that. This worked, I will say, whereas the previous two didn't really work at all. This works, but not super well. And then the best thing, I found this on Etsy. You can only find this on Etsy from a vendor in the UK. It's called Cat Music. I'll include a link, but it's conductive graphite paint again, and this works excellently. So this is what I'm going to be using with just a little paintbrush to coat that part that we have drying right now from the brake cleaner. So here we go with this Cat Music paint. I'm going to stir it up a little bit and then apply. And I'm actually going to do 2 coats once this one fully dries. Obviously taking some detail to get the paint in every nook and cranny of the part that we're trying to do, so it's going to take me some time to flip the part and paint the other side, etc. But we've got time while we wait that 6 hours for our acetate solution, aqueous copper solution to form. So we're going to be testing the different conductive coatings by measuring the resistance. So obviously you want the lowest resistance possible. That'll mean the highest amount of current, which is what we're going for. So I'm going to start with so we got our multimeter. I got it set on the highest measuring for resistance right now. Hopefully you guys can see this. So I'm going to test. So this is currently the first one is it's the powdered graphite and acetate. And as you can see, even in the highest resistance setting of what is that, 200,000 ohms, I can't get a reading even with the contacts of my multimeter pretty close together. So basically it's over 200,000 ohms. So that one doesn't really work. So now we'll move on to the one that I did with multiple coatings of the spray-on graphite. So that's only like 0.004. So let's change the measurement down to 200. Or sorry, so the last one was 2 million ohms. So this is now at 200,000 ohms, still getting a reading. 20,000 ohms, we're getting a reading. I don't think we're going to get one at 2,000. Nope. So at 20,000 ohms, we're reading about 4-ish. So it's about 4,000 ohms resistance for this one. And so last, we're going to go over, we'll start right here and go over to our new part that we just painted with that graphite from the United Kingdom. And so we're getting a very low reading at 20,000, so let's drop it down to 2,000, still getting something. And then down, measuring only 200 ohms, we're getting 3.2 ohms. So that is a crazy difference. So the resistance of this one is only 3.2 ohms. This one was like 4,000, and this one's over 2 million. I misspoke earlier when I was saying 200,000. So huge difference in the quality of this paint. So if you're going to buy anything for this project, I would buy this paint and wait for the shipping time. So yeah, that's how we're going to test, and that's why we're using this paint. So this is where it can get a little tricky. So we're going to try to do some rough calculations to figure out basically the power settings for our electroplate bath. So what I've read online, so this is the general rule of thumb, is you want 0.07 watts of power per inch squared of surface area. So for our case, we have this little rectangular Prusa piece. I measured it at 3.5 inches by 1 inch. So the surface area is 3.5 inch by 1 inch by the two sides, so 7 square inches. So that 0.07 watts per square inch times 7 square inches is 0.49 watts. And now a watt is equal to a volt times current. And so for my case, I'll go a little bit more in depth into this in a second. I'm using a constant voltage source at 6 volts. So I know my voltage is constant. So to find current, I just do the 0.49 divided by 6 and I get about 0.08 amps. So that's what I want. So here's a little depiction of what our bath is going to look like. So we're going to have the positive lead going to the anode, which is going to be spare copper in the bath. And then we're going to have the cathode connecting right to the piece that we're plating. And so this is the negative lead. Again, I'll show you this in real life. But so this internally is going to have some sort of internal resistance, right? And so in our case, we're using a constant voltage source of 6 volts, and we can't adjust the current manually. So there are other ways that you can manipulate the current by manipulating the resistance. So if we're going to do the setup just like this, it's going to just have some resistance. We'll call it X ohms because we don't know what it is, but it's some fixed amount, right? However, what we can do is come over here and add in some resistors in parallel. So that's the symbol for a resistor, and then we're going to add some. Hopefully you guys can see that. So I just drew in, so we basically added in 4 resistors here in parallel. We'll call these resistors with a resistance of R. So when you add resistance in parallel, this becomes your new formula. So we have the original resistance, X, plus 4 times 4 of the R resistors here, and our total resistance is going to be, this is the formula for it. So I'll let you guys do the math yourself, but basically the lower your R number is, and the more of them you add, the lower your overall resistance is going to be. So for me, I'm using 220 ohm resistors just because that's what I had on hand. That's the smallest that came with the kit that I bought previously. So that's going to lower my resistance, thereby increasing my current. So again, I'll show you what this looks like in real life, but just know this is the math for trying to figure out approximately what kind of voltage, current, resistance you're trying to use, and we'll get into more details about the power source and how to set all that in a second. Alright, so getting into the power source. So ideally, you can buy on Amazon, I can link some, but they're $100 to $200, some constant current, maybe constant voltage power sources that you can manually adjust with little potentiometers to get just a precise amount of voltage and current like we calculated. I am not going to do that. So I tried two different methods. I have this old 12 volt battery charger, so constant voltage. It has an option for 6 or 12 volts. Generally, if you go a little bit too high with the voltage, it might like kind of burn the part, so I've been mainly using 6. Another thing I tried was an Arduino and breadboard. So this I can kind of write my own code and write my own voltages and currents a little bit, and also just put in resistors like I said. However, this is just a very small power source, and I found it wasn't actually strong enough. Oh boy, did not mean for that to happen. Yay. That was not supposed to happen. Here are those 220 ohm resistors that I talked about. I wired them just like that in parallel, and I'll show you how it all ties in a second. But for my application, basically, I'm going to be using this 6 volt battery charger, and we'll get into this in a second once I clean this up. Some final preparations for this bath before we go to use it. I'm going to remove this copper and have a new copper anode that I'm going to cut from that wire that I have. You can reuse this copper, but anyway, like I said, I'm going to put on some gloves and remove it. And the last thing we're going to do is you're supposed to add basically the same amount of vinegar we added to form the solution in the first place. We're going to add that same amount of vinegar again to this solution. So I'm ready to start my bath here. I've got my 6 volt battery charger plugged in. The positive end is going to a new batch of copper that's going to be the anode that I cut. So I can place that. Alright, place that right here at one end. Clip that. There we go. Then my negative end is going to the part that I'm plating. And we can, so I could use an alligator clip if I didn't want to put this directly in the water, but so I'm going to put this in here. So note that the distance from the anode matters. You can experiment with changing the distance. You definitely don't want them to touch, but basically the closer the distance, the quicker it should plate, but also the higher risk of burning, and the farther away, the longer it should take, because you're basically changing that resistance by moving it closer or farther away. But so we're going to try it just like this for a moment. You can already see here, I'll show you. Hold on, let me adjust the camera. I don't know if you guys can see that, but it's already started to grab some copper. So also the more that you rotate this around, the better. So really, you want to be very hands-on with this step and making sure we do our best to change the distances and rotate it so it doesn't clump or whatever, so we get a nice, clean, even coat. And hopefully you guys can see there's some bubbles there too, especially very close to the end of the battery terminal. So I'm going to leave that for a second and show you guys. So again, I have my resistors wired in parallel with 2 clips. Doesn't matter the color, doesn't matter the orientation, but what I can do is take one end of the clip, hopefully you guys can see this, and clip it really anywhere. I could clip it right to that terminal, or I could clip it to this, and then this terminal I can clip to here. I want to show you guys something right here about my resistor trick. So you can see my battery charger has a little let's call it a meter right here that shows you the current. Right now it's showing maybe 0.75 amps. So behind the scenes I have the resistors not connected right now, and I'm going to connect them, and I'll let you watch this thing move as I connect. Did you see that? Sway just a little, went up just a little bit, now it's steadying out, might have gone up just a tiny bit, and then I'll remove them, and it drops. Connect them, and it goes up. So that's the resistor trick. Well, I'm going to leave this in longer as an experiment to see just how it gets when it goes in for a really long time. But what I found works best is kind of the mid-range here distance. Too far back, it almost didn't seem to do anything, and too close, it definitely started to burn. You can see some right there. I also seem to find that right where the clip here connects, it seems to burn. So it might be better if you had some thin, really basically high gauge wire to wrap around the piece and then connect that to the clip and then kind of dangle it in. That would probably work best, and you'd get a more even connection, right, if you could really wrap this in some thin gauge wire. But yeah, pretty good, and I'll try to show you some examples of just what the paint looked like and link everything in this description. But yeah, that's about how to do it. So here is the copper paint that I found, which, by the way, like I said, is not conductive, but here's what it looks like. So this is, I painted the bottom half of this trophy with primer first, just some spray on, and then the copper paint, and then this is just the copper paint. And as you can see, so it actually looks pretty good. So if you're just going for looks, this might be a good option for you. Again, I'll have the link in the description.